we'll be discussing about Physics Paper 1 MCQ paper 2015 October-November, variant is 12 and the subject code is 9702. Number 1. Which list shows increasing length from beginning to end? So increasing length, that means since all are ones, so the highest length would be centimeter, then millimeter, then micro, then nano, and centimeter is 10 to the power negative 2, millimeter is 10 to the power negative 3, micrometer is 10 to the power negative 6, and nanometer is 10 to the power negative 9. So this is the sequence. In question number 2, which equation contains only scalar quantities? Scalar quantities means that the quantities that have magnitude only. So this quantity is a scalar because power is a scalar, work is also a scalar, and time is a scalar. But acceleration is a vector, then force is a vector, then velocity and displacement both are vector. Also here force is also a vector. In question number 3, the time taken for a satellite to orbit the earth. So this is the equation we have given. Then what are the SI unit of k? So we need to find SI unit of k. So we rearrange the equation and make k becomes a subject of formula. Then the SI unit of t is second, mass is kg, and r, what is r? So r is the radius, that means it is a distance, so its SI unit is meter. So after substituting the values we get this equation, and this is similar to kg second square per meter cube, so C. In question number 4, which row gives a reasonable estimate for mass and speed of an adult running? So mass would be around 60 to 70, that is average mass. So it could be 6 into 10 to the power 1, but it cannot be 6 into 10 to the power 0 because 6 into 10 to the power 0 means 6 into 1, that is 6. So the mass cannot be 6 kg. So the answer could be either B or C. Then what is the speed? So an average speed is around 10 meter per second, but it cannot be that 5 to the power 1 means 50. It cannot be 50 meter per second. It could be either 5 or 5. So the answer is B. 5. What are the best estimates of the percentage uncertainty in the value of G? To calculate the percentage uncertainty, we know the uncertainty in the value of L and T. So first of all we need to make G becomes a subject of formula. Then percentage uncertainty in G is equal to percentage uncertainty in L plus, since T to the power 2, so 2 into percentage uncertainty in T into 100%. So percentage uncertainty in L, that is approximate uncertainty divided by value, plus percentage uncertainty in T, that is 2 into approximate uncertainty divided by value into 100%. So we get the percentage uncertainty as 15.62, or corrected to significant figure it would be 16. So the answer is D. The diagram shows two complete pulses on the screen of cathode ray oscilloscope. The grid of 1 cm squares covers the screen. The time base setting is 1 microsecond. 1, yes, it is micro. So micro means 10 to the power negative 6. That is 10 to the power negative 6. So 1 microsecond. Then how long does each pulse last? So it does not mention that the distance between the two pulses, but it mentions about how long each pulse lasts. That means suppose this is the pulse, so each pulse lasts for 2 microsecond. So it would be 2. Since one box is 1 microsecond, so 2 boxes 2 microsecond. Question number 7. A boy throws a ball vertically upwards. It rises to a maximum height where it is momentarily at rest and then falls back to his hands. Which row gives the acceleration of the ball at various stages in its motion? Take vertically upwards as positive. So vertically upwards is positive, ignore air resistance. So we basically know that when a ball that is moving upward, its velocity decreases. Since velocity decreases, thus acceleration has a negative sign. But for movement downwards, we know that velocity increases. For movement downward, the velocity increases, thus acceleration has a positive sign. And we know that acceleration is a vector quantity, so it has both magnitude and direction. So acceleration has both magnitude and direction, and we know that for movement of upward, So for rising, that is upward movement, the direction or is negative. So the direction is negative, but here we have to take vertically upward as positive, so we have to take positive, and if we just multiply these two values, then we would get a negative sign. That is, acceleration is negative, so either B or A. Then for movement downwards, we know that velocity increases, and since velocity increases, thus acceleration has a positive sign, so acceleration has a positive sign. But as we know that vertically upward is positive, so vertically downward is negative, so it would be negative, that is magnitude is negative. Then if we just multiply it, then we would get a negative value. So acceleration is negative for falling, and since rising the acceleration is negative, for falling the acceleration is negative, that means at maximum height the acceleration is also negative. So the answer is B. Question number 8. The curved line PQR in the velocity time graph of a car starting from rest. So this is PQR, and this represents the acceleration, since the gradient of velocity time graph is the acceleration and the area under the velocity time graph is the displacement. So what is the average acceleration of the car over the first 5 seconds? So over the first 5 seconds, that is from P to Q, what is the average acceleration? So average acceleration is basically the gradient of the graph, but since the gradient is a curve, so we have to take a straight line, that is this dotted straight line. So the gradient would be the gradient of the straight line PQ, that is the gradient of the straight line PQ. So the answer is C, but the gradient of the tangent at Q would give the acceleration at point Q, not the acceleration at PQ. And the area under the triangle gives the area under the velocity time graph gives the displacement. So this is not acceleration. Number 9. A ball is released from rest above a horizontal surface. It strikes the surface and bounces several times. The velocity time graph for the first two bounces are shown. What is the maximum height of the ball after the first bounce? So initially the ball is at rest at a height that is above the ground. So suppose the ball is above the ground and the ball is released, then the ball falls, then it again rises, then again it falls, then again it rises. So what is the maximum height of the ball after the first bounce? That means this is the first bounce, and after the first bounce what is the maximum height? So to find the maximum height, the ball is initially at rest at the top of the plane. So at the top of the plane it is at rest. Then before it hits the ground, it has a maximum velocity, that is this velocity, and after it hits the ground, it starts to move in a negative direction, that is initially it is moving downward, so downward is positive, then again it moves upward, so upward is negative, so again it starts to move upward. So it is negative direction, that is starts from negative value, then it reaches a maximum height, and at maximum height velocity is 0. So after the first bounce, the maximum height is this point, that velocity is 0. So from this point to this point we need to determine the maximum height. So area under the velocity time graph gives the displacement of the maximum height, that is this area. So area would be half into base into height, and the height is 2 and the base is 50 minus 30, that is it would be 50 minus 30, that is 50, that is 0.50 minus 0.30. So the answer we get is 0.20 meter, that is A. Number 10. A bus takes a time of 25 seconds to reach a constant speed while traveling in a straight line. So it takes 25 seconds to reach a constant speed. Then a graph of speed against time is shown. Which graph shows the variation with time of the resultant force of the bus? So for resultant force against time graph, we know that resultant force is equal to mass into acceleration, where mass is constant. And what is acceleration? Acceleration is the gradient of the velocity time graph. So initially the gradient is constant and increasing, so acceleration is constant. So acceleration is constant, then again the gradient is constant and increasing, so acceleration is constant. Then here we can see that at this region the gradient decreases, so acceleration also decreases. So it decreases until 25 seconds, so it decreases until 25 seconds, So the answer should be A. Question number 11. A single horizontal force F is applied to block X, which is in contact with a separate block Y, as shown. The blocks remain in contact as they accelerate. So as the blocks accelerate, they remain in contact. That means the acceleration value is same. And the acceleration value is same because if suppose the acceleration value is different, then one would move further and the other would move slower. But since they remain in contact, that means the acceleration is same. Along a horizontal frictionless surface, at here resistance is negligible, X has a greater mass than Y. So the mass of X is greater. Which statement is correct? We know that force is acting and the blocks accelerate. So we know the equation, that is force is equal to mass into acceleration. And what would be the acceleration of X? So acceleration of X is equal to force of X divided by mass of X, and acceleration of Y is equal to force on Y divided by mass of Y. So we know that the mass of X is more. So mass of X is more, and we know that acceleration value remains constant since they are in contact. So they have the same acceleration. So acceleration is same. Now acceleration is same and the mass of X is more. So the force on X is obviously more to make acceleration constant. And since mass of Y is less, so force on Y is also less to make acceleration constant. So force that X exerts on Y is less than F. So the force that X exerts on Y, that is Fy, is less. So Fy is less than F. So Fy is less, as we can see that Fy is less than F. So the statement C is correct. Question number 12. A mass of 0.20 kg is suspended from the lower end of a light string, that is this mass. A second mass of 0.10 kg is suspended from the first mass by a thread. The arrangement is allowed to come into static equilibrium. Since the system is in equilibrium, that means the resultant moment is 0 and the resultant force is 0. That means if we consider the initial position, then this value of tension is same as this value of tension. Now the thread is burned through. Now the thread is burned, so the 0.10 kg mass would move downward and the force is acting downward due to gravity, and the 0.20 kg mass is moving upward. And we know that initially at equilibrium the resultant force is 0. Thus after the thread is burned by Newton's third law of motion, we know that if body A exerts a force FAB on body B, then body B will exert an equal and opposite force. So basically the forces are equal and opposite, that is F. So what is this force? Okay, so first of all, at this instant, what is the upward acceleration of 0.20 kg mass? So we need to find the acceleration of this mass. To find the acceleration, we know that resultant force is equal to mass into acceleration, but we need to find this value of force. And from 0.10 kg mass, we know that the same force is acting, and since it is moving freely, and so the acceleration value is given, that is 10. So the force would be 0.10 into 10, that is mass into acceleration. So the force we get is 1 Newton. So the upward force is also 1 Newton. So this value of force is 1 Newton, that is 1 Newton, and we know that it's mass. So mass is 0.20 and we need to find its acceleration. So after substituting the value, we get the acceleration as 5, that is 5 meter per second square. Number 13. An object of mass m is traveling with a velocity v. So this m is traveling with a velocity v, has an head-on collision with another object of the mass m. So it collides with the same mass m, and both have the same mass and traveling at the same velocity in the opposite direction. So they have the same mass and they have the same velocity, but the velocity is in opposite direction. The two objects stick together after the collision. So after the collision, the two objects stick together, that is, two objects stick. What is the loss in kinetic energy? Total loss in kinetic energy in the collision. To find the loss in kinetic energy, first of all, as the same mass objects collide with the same velocity, that means after collision the velocity is 0. So basically the after collision the velocity is 0, since the mass is same and the velocity is same. So after collision this velocity cancels with this velocity, so ultimately the velocity is 0, and we need to find the loss in kinetic energy. So loss in kinetic energy would be half into mass into speed square, that is half into mass into this speed square, that is v, and half into mass into speed square, that is this speed. And since we are considering the speed, not the velocity, so the speed is positive whether it is in this direction or this direction. So the speed value is positive, and we get the change in kinetic energy or loss in kinetic energy as mv square, and the final kinetic energy is 0 since the velocity is 0. Two identical spheres x and y approach each other with speed shown and undergo head-on elastic collision. So they undergo elastic collision. So as they are identical spheres, so they have the same mass, that is sphere x collide with sphere y, and after collision, since they have the same mass, so they would move in opposite direction. So opposite direction. Now which velocities of the spheres after collision are correct? So basically they would move in opposite direction. And what are the velocities? So we know the formula since they collide elastically. So u1 v1 is equal to u2 v2, and we know the value of u1 and u2, and we need to find v1 and v2. So we get, after solving, we get v2 minus v1 is equal to 2, and so v2 minus v1 is equal to 2. So v2 is y minus x is 2. So y minus x, that is 4 minus 2 is 2. So this would be correct. Then 4 minus 2 is 2. This is correct. But 2 minus 4 is negative 2. So this is wrong. So either B or C. Then we can say that after collision they would move in opposite direction. So they would move in opposite direction, that is C. They move in opposite direction. 15. Which pair of forces act only as a couple on circular objects? So you must remember the definition, that is a couple consists of two forces. So two forces of equal magnitude but act in opposite direction. So the forces of equal magnitude but act in opposite direction whose line of action do not coincide. So among the options, two forces of equal magnitude, this is not an equal magnitude, this is not an equal magnitude, and this is equal magnitude, but the forces act in opposite direction. This is not acting in opposite direction. If the force is acting in this direction, then this would be the answer, but since they are not acting in the opposite direction, so this would not be the answer. Then for option A, we can see that forces of equal magnitude that are acting in opposite direction whose line of action do not coincide. And line of action do not coincide means that the force is not acting in this place. So the force is not acting in this place. Okay, the forces of equal magnitude acting in opposite direction whose line of action do not coincide, and we know that the formula for couple is force and the perpendicular distance between the forces. So force and the perpendicular distance between the forces, and their forces must have the same magnitude, so the answer should be A. 16. A car of mass 500 kg is at rest at point X on the slope as shown. So it is at rest at point X, that means at point X speed is 0. So kinetic energy is 0 at this point. The car's brakes are released and the car rolls down the slope when the engine is switched off. Since the engine is switched off, that means there is no driving force acting. At point Y, the car has moved a vertical distance of 30 meter and has a speed of 11 meter per second. So at point Y, it has a speed of 11 meter per second and it has traveled a vertical distance of 30 meter. What is the energy dissipated by frictional force? So energy dissipated by frictional force, that means work done against friction when the car moves from X to Y. So this is a simple mechanics question, and we know that at point X, initially the speed is 0 and there is no driving force acting. So initially it has gravitational potential energy, that is mass into gravitational field strength into vertical height, is equal to the final kinetic energy, since at the final, or if you take this as a base, then the gravitational potential at this point is 0, plus kinetic energy, since it has some speed, so it has obviously some kinetic energy, plus work done against the resistance. So work done against the resistance comes to be 1.169 into 10 to the power 5. Correct to significant figure, it would be 1.2 into 10 to the power 5. So the answer is B. 17. In which situation no work is done? So we know that work done is the product of force and the distance moved by the object in the direction of the force. So for the first case, the air in a bicycle tire is released because of puncture. Suppose this is a bicycle tire and due to the puncture air is released, and as air is released, the force of air causes it to release. The force of air inside the tire causes the air to release, and as the air is released due to the force, some distance is covered, so obviously there is some work is done. Then a ball is dropped and falls to the ground. Suppose this is the ball and it falls to the ground, and it falls to the ground because of its weight. So force due to weight, and as it falls it covers a distance, so work is done. Then in option C, a box moves at a constant speed across a smooth horizontal surface. So suppose this is a smooth surface, and since the surface is smooth, there is no frictional force, that is force due to friction. Also, as it moves at a constant speed, so there is no frictional force, also there is no driving force, because if some driving force is acting, then it would not move at a constant speed. Since it moves at a constant speed, that means forward force is equal to backward force, and since there is no backward force, thus there is no forward force. So no forward force is acting, or no force is acting, and so no force is acting, so no work is done. So the option could be C. Then option D, a crane lifts a steel grider at a constant speed. So this is the crane that is lifting, and this is the grider. As the crane lifts the grider, so there is some force acted by the crane on the grider, and this force is represented by force due to tension. As the force acts on the grider, so it moves upward, and as it moves at a constant speed, that means the force due to the crane is equal to the weight of the grider, that is the force due to weight. And since these two forces are acting at equal amount, so it moves at a constant speed. And though it is moving at a constant speed, but we can see that there is some forces acting, and as force is acting, also some distance is covered, so here also work is done. So work is not done in option C, because as it moves in a smooth surface, so there is no frictional force is acting. Also as it moves at a constant speed, so there is no forward force is acting, and since no force is acting, so no work is done in option C. Number 18. An electric railway locomotive has a maximum mechanical output power. So this is the output power, 4 megawatt. So output, and electrical power is delivered at, so this is the voltage, that is 12 kilovolt from overhead wires. The overall efficiency of the locomotive in converting electrical power to mechanical power is 80%. So initially the power we have given is the output power or the mechanical power, and the electrical power is not given, and the mechanical power that we get is the 80% of the total power or the electrical power. What is the current from the overhead wires when the locomotive is operating at its maximum power? So maximum power, and we need to find the current. So what would be the maximum power? Maximum power means initial power, and this is the output power. So output power is 80%, so 80% is the output power. So what is the maximum of the initial power? Initial power is 100%, so 100% would be, we need to calculate, then we get 100%, that is output power divided by 80 into 100. So this is the input power or the total power. We know the power, and we know the equation power is equal to voltage into current, and we need to find the value of current. So current is equal to power by voltage, so 25 kilo, that means 10 to the power 3 volt. After substituting the value, we get the current as 200 ampere. Number 19. The table summarizes some descriptions of evaporation. Which row about the table is correct? Involves a change in state from a liquid to a vapor. Yes, evaporation causes a liquid to change its state to a vapor, so this statement is true. Then occurs at a fixed temperature. Boiling occurs at a fixed temperature, but evaporation occurs at any temperature, so this statement is false. Then involves a reduction in the average kinetic energy of the remaining atoms. So as evaporation occurs, more energetic molecules from the surface of the liquid evaporate, and the less energetic molecules are left behind. So as more energetic molecules escape, so the average kinetic energy of the remaining molecules decreases as the more energetic molecules escape. So the average kinetic energy of the remaining molecule decreases. So this statement is true. So the answer is B. D. So what is the difference in the pressure between x and y? X and y. So x is this point and y is this point. So we know that pressure is equal to rho gh, where rho is the density, we know the value of density, g is the gravitational field strength, that is 9.81, and what is h? H is the vertical height. H is the vertical height. So what is the vertical height? We know the total vertical height and this vertical height. So total vertical height minus this vertical height, we would get the difference in the height. So this is difference in the height, and we need to calculate the pressure for this difference in pressure. That means we need to calculate the difference in pressure. So the difference in height is this height. So we substitute the difference in height in the equation to calculate the difference in pressure, that is 3.4 kilopascal. Number 21. A force acts on a wire produces an extension E. So this is the extension E. The same force then acts on the second wire of the same material but have half the diameter and 3 times the length. So the diameter is half and length is 3 times then of the first wire. Both the wires obey Hooke's law. What is the extension in the second wire? So we need to find the extension in the second wire. So for the first wire, what is the extension? We have found the extension, that is 4f. Since we have not given the value of force, so we consider it as f. Also we consider the length as L pi d square E. So this is the first extension, and for the second extension we know that length is 3 times, so 3L, and the diameter is half, so diameter divided by 2 square E. So after calculating, we can see that if we compare this value and this value, we can see that the final extension is 12 times the first extension. So the final extension is 12E, that is 12E. Into which statement about elastic and plastic deformation is correct? Elastic and plastic deformation are proportional to the applied force. So elastic deformation is proportional to the applied force, but plastic deformation is not. Then elastic and plastic deformation causes no change in volume. So elastic and plastic deformation cause no change in volume. This statement is controversial, so it could be. Then elastic deformation causes heating of the material, but plastic deformation does not. Again, elastic deformation causes heating. So elastic deformation causes heating. Again, this statement is controversial. Then in option D, elastic deformation is reversible but plastic deformation is not. Yes, this statement is obviously correct because elastic deformation is reversible but plastic deformation cannot be reversed. So this statement is obviously correct. So the answer is D. 3. What is meant by ultimate tensile stress of a ductile material? So ultimate tensile stress would be the maximum stress that a material can support without breaking. So maximum stress that a material can support without breaking. So this point is the ultimate tensile stress. So the answer is C, that a maximum stress that a material can support without breaking. 24 is 0.80 length of steel wire. So the length we have given, and the 1.4 meter length of brass wire. So 1.4 length of brass wire are joined together. The combined wires are suspended from a fixed support and a force of 40 Newton is applied. So for both the wire, the force is same, that is 40 Newton. The Young modulus of the steel is given. So this is the Young modulus for the steel and this is the Young modulus for brass. So this is the Young modulus for brass, and each wire has a cross-sectional area given. So both the wires have the same cross-sectional area as 2.4 into 10 to the power negative 6. Then the wires extend without reaching the elastic limit. So the wires extend without reaching the elastic limit. Now what is the total extension? Ignore the weight of the wires. So we need to find the total extension. So we know the Young modulus is equal to force into length by cross-sectional area into extension. So we need to find the extension, that is the extension of steel and extension of brass. Then we need to just add these values. So what is the extension of steel? So extension is equal to force into length by Young modulus into cross-sectional area. So we know these values and we find the extension of steel. Then we know the values for extension of brass and we found the value. Then we need to just add the total extension, the extension of steel and the extension of brass, to get the total extension as 3 into 10 to the power negative 4 meter. 25. Which of the following wave motions may be used to demonstrate the phenomena of polarization. So what is a polarized wave? A polarized wave is a transverse wave in which vibrations occur in only one direction. So vibration occurs in only one direction at right angle. So the vibration occurs in only one direction and at right angle to the direction in which the wave energy is traveling. So a polarized wave is a transverse wave in which the vibration of the particle occurs in one direction at right angle to the direction in which the wave energy is traveling. So, and it must be a transverse wave. So in option A sound wave from a thunderclap. So since it is a sound wave, so it is a longitudinal wave, so we cannot form a polarized wave from this. Then the surface of water, then the surface of wave in a water ripple tank. So since it is a water wave, so it is a transverse wave, so we can use this. Then a stationary wave in a organ pipe. So an organ pipe is used to produce sound, and sound is a longitudinal wave, so we cannot use this. Then a stationary wave in a stretched wire. So a stationary wave in a stretched wire, that is suppose this wave, so we can use this to form polarized wave, because the wave that is produced is obviously transverse wave, and after polarization the waves moves perpendicular to the direction in which the wave energy or the wave is traveling. That means the particles travel or the rope vibrate in only one direction, that is perpendicular to the direction in which the wave energy is traveling. So the more appropriate answer is D than compared to B. And why I choose option D? Because as stationary wave is formed, so suppose this is a straight string and a stationary wave is formed. So this is a stationary wave, and in stationary wave you know that the vibration occurs perpendicular to the direction in which the wave energy is traveling. So, and what are the particles? Suppose these are the nodes of the stationary wave and these are the antinodes. So antinodes would vibrate up and down from the mean position and nodes remain still. But for water wave, what happens in water wave, that though the particles vibrate perpendicular to the direction in which the wave energy is traveling, but some of the particles may travel here and there. So this could not be a proper definition for the polarized wave. But for stationary wave, we know that the nodes are obviously stationary and the antinodes would vibrate only up and down from the mean position. And since they vibrate up and down from the mean position, that means they vibrate perpendicular to the direction in which the wave energy is traveling. So the more appropriate answer that we can use to form polarized wave is D. The diagram shows the screen of cathode ray oscilloscope CRO displaying wave. The time base of the CRO is 10 millisecond per division. So the time base means that one box is 10 millisecond per division. So what is the frequency? We know that frequency is equal to 1 by time period. So what is the time period? Time period is the time taken to complete one complete wave, that is this wave. But here we can see that though it covers 4 boxes, but it covers an extra box, some of the extra box. So we just ignore that and we take an approximation of this value. So in actual we take 4 boxes, so 4 boxes and the time value for each box. So we multiply this to find the time period. So we know the value of time period. So what is the frequency? Frequency is 1 by time period. So we just place the value that is 1 by time period to find the frequency, and the frequency we get is 25. But what is the value that is close to 25? So the value that is close to 25 is 24 Hertz. And why the value comes 24 Hertz instead of 25? Because we ignore this point or these small values. So the value approximation to this answer is 24 Hertz. So the answer is D. Number 27. P is a source emitting infrared radiation. So P emits infrared radiation, that is IR, infrared radiation, and Q is a source emitting ultraviolet radiation, so UV. So which row is correct? So we have given the wavelength. So what is the wavelength of infrared radiation and what is the wavelength for ultraviolet radiation? So we know this data, we must remember this data. That is for radio wave, the wavelength is 10 to the power 4 to -1, microwave -1 to -3, infrared radiation -2 to -6, visible light 4 into 10 to the power -7 to 7 into 10 to the power -7, ultraviolet radiation 10 to the power -7 to 10 to the power -9, X-ray 10 to the power -9 to 10 to the power -12, gamma ray 10 to the power -10 to 10 to the power -16. So these are the values that you must remember, and if you compare, then what is the wavelength for infrared radiation? So it is between 10 to the power negative 2 to 10 to the power negative 6, and the more appropriate answer is 5 into 10 to the power negative 5, so it could be either A or B. Then what is the wavelength for UV radiation? So UV radiation is 10 to the power negative 7 to 10 to the power negative 9. So negative 7 to negative 9 is 10 to the power negative 8. So it could be either A or C, but the answer is C. But the answer is A because this value and this value matches with A. The diagram shows a tuning fork above a tube of air of length 25 cm. So the tube has a length of 25 cm. A stationary wave is set up in the tube with the same frequency as the tuning fork. So it has the same frequency. The lower end of the tube is sealed. So this end is sealed. This is the minimum length of the tube with the lower end sealed and creates a stationary wave. So this is the minimum length that creates a stationary wave. What are the other lengths of the tube sealed at the lower end that will also create a stationary wave? So basically for this question we have an open end and a closed end, and here stationary wave is formed. So the first stationary wave is formed in this way, and its wavelength that is covered is lambda by 4. The wavelength increases in such a way that lambda by 4, 3 lambda by 4, 5 lambda by 4, 7 lambda by 4. So lambda by 4 is equal to the length. So what is the value of lambda? Lambda is equal to 100. By calculation lambda is equal to 100. So we know the value of lambda, and since the same stationary wave is used, so what are the other lengths of the tube? So L is equal to, now we have used lambda by 4, then 3 lambda by 4, then 5 lambda by 4. So we use these equations and substitute the value of lambda, that is 100, in these equations to find the value of L as 75 and 125. So the lengths would be 75 and 125 as the other lengths. That both the ends are open, then the wave that is formed is in this way. So the wavelength is approximately, so it is a total wave, so the wavelength that is covered is lambda by 2. So the wavelength increases in such a way that lambda by 2, then 2 lambda by 2, then 3 lambda by 2, then 4 lambda by 2. This is the order of increase. Then question number 29. White light consists of many wavelengths. The wavelength of red light R is approximately twice the wavelength of violet light. So the wavelength of red light is twice, or the wavelength of red light is more. When white light is incident normally on the diffraction grating, several spectra can be formed. Which diagram shows the possible distribution of light in the first order and the second order spectra? So we know the equation for the diffraction grating, that d sin theta is equal to n lambda, where d is constant since 1 by n is constant, where n is the number of lines. So number of lines per meter is constant, so d is constant, and n is also same. Now n is same because here we have given that the first order and the second order, that is first order and the second order, so n is also same. So we get a relationship that is sin theta is directly proportional to lambda, and since we know that the wavelength of red light is more, so sin theta is more for red light. So since sin theta is more for red light, that means the angle is more for red light. So the angle is more for red light than compared to blue light, violet light. So the angle for red light is more, this is less, so this is wrong. Then also comparing red and violet light, the angle of red light is less, so this is wrong. But here we can see that the angle of red light is more than the violet light, so this could be the answer. Then the angle of red light is more than the violet light, so this could be the answer. So either C or D. Then the answer could be either C or D. Then if we just see what are the waves that are formed, then white light passes through the diffraction grating and it forms the zero order, then the first order and the second order. So we can see that the first order is formed in this way, then the second order is quite spread out. So the second order is quite spread out, so it would increase. So we can see that the answer D is obviously wrong, and the answer could be same as answer C. So the first order is quite spread out and the second order is much spread out, so it is answer C. It would be obviously answer C. Question number 30. To produce a stationary wave, two waves must travel in opposite direction through the same space. Which statement about the properties of the two waves must be true? So suppose this is the wave that is formed, and this is a stationary wave. So which statement about the stationary wave is true? So to produce stationary waves, two waves must have same frequency, same speed, same wavelength, and the waves are of same type. So the waves must have equal speed, frequency, wavelength. So the answer is C. Number 31. The question is related to electric field, so this is not in our syllabus. Then in question number 32, this is also from electric field, so not in our syllabus. In question number 33, which unit is equivalent to a coulomb? We know that the unit of charge is coulomb, so we know that charge is equal to current into time. So 1 coulomb is equal to 1 ampere second. So 1 ampere second. Then in question number 34, the graph shows the IV characteristics of an electrical component. Then what is the component? So first of all, what is the IV graph of a filament lamp? So this is the IV graph of a filament lamp, and as we can see that initially it is a constant line or a straight line because current is directly proportional to voltage, but as voltage increases, current increases. As current increases, heating effect increases, and as heating increases, resistance increases. So as current increases, heating effect increases, and so resistance increases, and as resistance increases, current again decreases. So the graph would something look like this for a filament lamp. Then for a metallic conductor at constant temperature, it would just be a straight line with a constant gradient. Then the graph of a semiconductor diode. So this is the actual graph for a semiconductor diode, because as it is a semiconductor diode and it is represented by this symbol, so this would conduct current in only one direction. So in this negative direction it would not conduct, but in the positive direction it would conduct at a greater rate. So this is the graph for a semiconductor diode. Then what is the IV graph of a thermistor? So for thermistor, we know that for thermistor, resistance is inversely proportional to temperature, and for also light dependent resistor, resistance is inversely proportional to light intensity. But for now, for thermistor, resistance is inversely proportional to temperature. So as voltage increases, voltage is directly proportional to current, so current also increases. Then as current increases, the heating effect increases, and as heating effect increases, and we know that resistance is inversely proportional to temperature, so heating effect increases, thus temperature increases, and as temperature increases, so resistance decreases, and as resistance decreases, current again increases. So current increases at a higher rate. So this is the IV graph of a thermistor, that is D. But our actual answer is semiconductor diode, that is option C. 35. A power supply has an EMF of 12 volt and an internal resistance of 2 ohm is connected with series with a load resistor. So it is connected in series with a load resistor R. Then also it has some internal resistance, that is small r. Then the resistance of the load resistor is varied between 0.5 ohm to 4 ohm. So the resistance of the load resistor can vary between 0.5 ohm to 4 ohm. Which graph shows the power, that is P, dissipated in the load resistor varies with the resistance of the load resistor. So these graphs are basically power against load resistance. So power against load resistance graph. So which graph is the power against load resistance graph? If you search from the books that for S level, you can see that the power against load resistance graph is something look like this. So this is the actual power against load resistance graph from the book. So this graph is quite similar to option A, so the answer should be A. That power against load resistance graph, you must remember this. So the answer should be A, that is similar to this. 6. The diagram shows the arrangement of resistors. What is the total electrical resistance between X and Y? So between X and Y, what is the resistance? So we can see that these three components are arranged in series, but this component and this component is arranged in parallel. So first of all, the resistance for the series is 10 plus 10 plus 10, that is 30, and for parallel circuit, we know that since this resistor and this total resistor are arranged in parallel, so for parallel circuit, the resistance would be R is equal to 1 by R1 plus 1 by R2 inverse. So this is the resistance, and it is between 1 to 10 ohm. So the answer is B. 7. The electromotive force of power supply is 120 volt. So the EMF is 120 volt, it delivers a current of 1.2 ampere to a resistor of resistance 80 ohm and a current of 0.40 ampere. So for this resistor that is arranged in parallel with the other resistor, we are given the resistance and the current. And to another 0.40, so in this resistor the current is 0.40. Now what is the internal resistance of the power supply? Okay, to calculate the internal resistance of the power supply, suppose at this point we consider the internal resistance, and the internal resistance is basically resistance. So internal resistance is equal to, or resistance is equal to, voltage by current. So we need to know, we already know the voltage, that is 120 volt, but the 120 is the total voltage. So we need to find the voltage for the internal resistance and the total current. We need to find the total current since the arrangement is in series. So first of all, for this resistor that is 80 ohm, we need to find its voltage, because since this resistor is arranged in parallel with this resistor, so the voltage is same. So what is the voltage of 80 ohm resistor? So voltage is equal to current into resistance, and we know the value of current and the resistance, so we calculate the voltage across 80 ohm resistor. That it is the voltage across this resistor is same as the voltage across this resistor since they are arranged in parallel. So we know its voltage and we know the value of current. So what is the resistance for this resistor? That is voltage by current, but we do not need to know its resistance because we already know the voltage in this parallel circuit, that is 96 volt. So what is the voltage across the internal resistor? So internal resistor voltage would be 120 minus 96. So the answer we get is 24 volt is the voltage for the internal resistor. And what is the total current? Since they are arranged in series, so the total current would be the current of 80 ohm resistor and the current of this resistor, that is added. So we add this value and we get answer of 1.6. So resistance is equal to voltage by current. So the resistance we get is 15 ohm. In question number 38, so the diagram shows the arrangement and two ammeters. Then the current in the 2 meters are identical. So the current in the two ammeters are identical, that means the arrangement is obviously in series. So which circuit within the box will give this result? So since the arrangement is series, so among these options the series component is only D. So the D would be the answer. Then in question number 39, a material contains a radioactive isotope that disintegrates solely by the emission of alpha particle at a rate of 100 per second. Which statement about the material is correct? So the number of atoms in this material diminishes at 100 per second. So alpha particles are 100 per second, but this is not atoms, these are alpha particle. Then the number of neutrons in the material diminishes at a rate of 100 per second. So alpha particle diminishes or removed by 100 per second, and we know that alpha particle contains 2 neutrons, that is 4 minus 2, so 2 neutrons. So the number of neutrons that is diminishes is 200 per second. Since each alpha particle contains 2 neutrons, the number of nucleons in the material diminishes at a rate of 400 per second. Yes, this answer is correct because nucleon number is the total number of protons plus neutrons. So in total, the proton and neutron, that is 4 proton and neutron by each alpha particle. So 100 alpha particle contains 4 into 100, that is 400 protons and neutrons, that is 400 nucleons. So the answer is C. Then for option D, the number of protons in the material diminishes is 100%, so this is wrong because each alpha particle contains 2 protons and 2 protons, so the number of protons that is diminishes would be 200, not 100. Then in question number 40, so a radioactive nucleus emits an alpha particle or a beta particle creating a product nucleus. Which decay process would create a product nucleus stated? So for the first option, alpha particle is emitted. So by the emission of alpha particle, we can see that the proton number should decrease by 2, so it is decreased by 2, and the neutron number should also decrease by 2, that means the nuclear number should decrease by 4, that is 4 2, so the nuclear number decreased by 4, but here we can see that it is decreased by 2, so this is wrong. Alpha particle is emitted, so alpha particle is 4 2, so we just need to subtract this and we get the number of protons. So proton number decreases by 2 but it increases by 2, so this is wrong. Then again, as beta particles are emitted, so what is the beta particle emission process. So neutron changes to a proton and beta minus particle is emitted. Also, since beta minus particle is an electron, so with electron antineutrino is emitted, and if it is positron, then neutrino is emitted. But since beta minus particle is emitted, so antineutrino is emitted. So for this question, so thorium 23190 decays and forms Pa 23191. So as we can see that the nucleon number remains the same, but the proton number increases by 1 since one more proton is formed, so the answer should be D.